Good morning. Can you hear my voice? Okay, good. I understand so that Hong Kong is in the difficult situation, so that you can see that in the past 2 or 3 weeks, Hong Kong, the number of this confirmed COVID-19 case keep increasing exponentially. So that again, I do hope all of you can be take good care of your health. So this is something very critical, and unfortunately, where a lot more people die now in the following thing. And if you look at those statistical prediction from the Hong Kong U medical expert, hello, can you hear voice? Oh, I'm muted. Oh, sorry. Let me check. Sometime I need to. Hello, how about now? Can you hear my voice? Hello? Okay, sorry. I sometimes the setting will have some problem. Okay. Anyway, so that as I told you, all of you understand that Hong Kong in a very difficult situation, and then so that I hope all of you will keep you healthy, and then try to do some exercise even in your own apartment and or student home, so that this is something quite important for all of you. So all of you, we are in very difficult situation. So of course, still remind you about this kind of one we just according to this our guest lecture, so that it's better you follow this kind of general guideline to prevent this kind of this kind of COVID-19 infection. So that this is something still remind you about this, and then so that I don't know how about you. I don't know if you or your family member got some problems or already got this virus or not. I don't know. Can you let me know? I also want to understand if you or because even our UST, I think we have more than 100 confirmed case. I don't know. Some so at least at UST we have more than 100 cases. So that I do hope that you all of you be very careful at UST. So it's something not it's non-trivial. Wow, we do have one student mentioned that white chin sound. Okay, so that means I'm sorry to hear that some of you already got in case you sound very serious, because our medical system will be going to crash, very similar to like Wuhan and New York City 1 or 2 years ago. So that a lot more people will be anyway. So that a lot more people will have some big difficulties. So this is something I do think is important. Of course, I for some actually I do have some special project work with Professor Carson in Hong Kong UST about how to work on some new kind of Chinese medicine using our mechanical engineering expertise, feedback control system, so that at least I do have some get in contact with our UST expert in working in Chinese medicine, TCM, for more than almost 25 years. In case you have some very serious symptom, so that need help, I don't mind, so that I provide this kind of information for you and your family member. Especially I understand some of the patient, some people will be very difficult, but most likely I would say 99% of people got this kind of Omicron is okay, but still some very small percentage will go to hospital, ICU, or die. I do hope if you need help, at least I will provide this kind of information for you, so that in case you need to have a medical advice, I don't mind to share with our UST TCN expert, Dr. Dong. Why? Dr. Dong actually has been working on this kind of 25 years research about develop some new this kind of Chinese medicine, so that actually my Dr. Dong's daughter also got this kind of COVID-19, and then Dr. Dong tried to use this kind of I think combination of Chinese medicine with Western medicine, and then help her daughter to recover. So that I just let you know that I can see the number of new cases were going to 100,000, or maybe say 1 million people in Hong Kong. So it's unfortunately maybe eventually everybody will get this virus, so that some small percentage will be very serious or die. I do hope that if in case you need help, I provide this kind of information for all of you, so that I do believe why this is important. Unfortunately, this kind of Western medicine, why this kind of thing, they have a very effective has some drug to treat this kind of bacterial or some kind of some disease from this kind of virus induced this kind of disease. Somehow Western medicine or this kind of thing, biology, thing have some limitation. So like HIV or some virus induced this kind of disease, as I told you, this kind of Western medicine do have certain limitation. Even for those flu, right? Traditional flu, you got this virus, right? Influenza. I told you, most of Western medicine is only relieve your symptom only. They don't really try to treat this kind of even the flu virus. But on the other hand, Chinese medicine do have look at the disease from very different angle. So that's why I can see that if you rely on Chinese Western medicine for this COVID-19, maybe one thing is maybe a lot more side effect. Another thing maybe it's not effective. Okay, so that at least I have 10 years research collaboration to work with Professor Casting, and then so that we have although I'm in the ME mechanical engineering, but I do have 20 years research in this kind of biomedical research, right? So that this thing, I just tell you that if you need help, please try to let me know. I can provide you this kind of advice from my own experiment collaboration with Professor Casting's lab, while he has also worked on this thing for almost close to 30 years, 25 years. Professor Casting in our HKUST Life Science is really his team has worked on traditional TCM for almost, I would say, 25 years. I also work with him and Dr. Dong on this kind of thing, and then so that I just tell you this is a difficult time. Yeah. Okay, so that if no other thing, then I think we should go back to our lecture. So that anyway, so this is something I do hope that all of you can really stay healthy. While another thing, I understand some students actually get some nervous, right? So that afraid of thing, but unfortunately, I don't think you can really control virus. You just try to make sure you increase your immune system. You do exercise every day, and then make sure you can be more resistant to this kind of a viral infection. This is something I think this is the only way you should think about. And then of course try to think about if you are able to have some technology to overcome this kind of thing. So technology, as mentioned, that's why we have a guest lecture. Okay, now we should go back to our lecture. So we already start a new chapter, this kind about smart building, intelligent building, and I'll quickly show you what we just mentioned last time. So that we hope that this kind of intelligent smart building has something improve the performance, right, of this building, conventional building, and in different aspects. For example, we want to have this kind of more efficient, energy efficient building. Safe, it means, for example, we have a lot more this kind of sensor or something, IoT system for fire safety. Comfortable, why? Comfortable is also critical, but it's also not easy. You think comfortable, is that easy or not? What do you think? Even our USD building, so that those kind of air conditioning system, do you have any complaint about UST? Huh? Any complaint? Many people complain, right? Too cold. Huh? Do you understand? And even in those kind of typical shopping mall or this thing commercial, this building, sometimes they try to have a very set point temperature of air conditioning system in very many buildings. It's set very cold. Do you understand? So why? This is a difficult issue in terms of building engineering. Do you understand? So that even it looks like as trivial, but in reality, actually, it's non-trivial to overcome these things, so that how to work energy efficient, safe, and comfortable. Of course, we'll have additional this kind of chapter in the following way to describe about something more detailed, right? So that we also mention about this kind of intelligent or smart building is not new. So that at least more than 40 years ago, people already come with this kind of idea. Why? But of course, in the past 40, 50 years, technology become much more advanced, especially, I would say, semiconductor technology, so that gradually we do use this kind of computer control system or some special type of computer, right? To work on this kind of automation. In the beginning, there's automated building and responsive building. Response, what do you mean responsive? Responsive means we are able to have, most likely have some additional sensor to send this kind of buildings, and then you can try to respond to different, maybe different kind of situation to be more intelligent. One student, Bo Yan Lee, actually mentioned super cold. But then the quick question, why? Why the air conditioning system in Hong Kong is super cold? This is very important issue. Why? Why this kind of building and a service engineer? Huh? They try to make this kind of super cold air conditioner, huh? Air con. Why? What's the reason? Super cold. This is very actually turned out to be something non-trivial. Actually, this is very non-trivial. So you see, so that I just show you here. We want to have a comfortable, right? So that comfort, if there's a certain kind of, I would say, now temperature, humidity, and also even human thermal comfort. This thing, so that you're comfortable, and then it's not super cold, right? 20 degree or degree C. Typical from Hong Kong government, they say about I would say about 24 degree is a typical temperature. 24 from EMSD of Hong Kong thing, they suggest about 24 degrees C. But why they want it super cold? Actually, it's non-trivial. So because they want to save energy, but also maintain good this kind of conditioning, and then so if you want to maintain very good 24 degrees C, and then also comfortable, so that sometimes you need to have additional way to reduce the humidity. Do you say we can say we control temperature, humidity, and the other thing, so that actually this is non-trivial. Hong Kong UST has some special kind of air conditioning system 25 years ago, and we have special way to control temperature and humidity. But what's the problem? It's more expensive. Efficient. It's not. It will you will actually spend much more money for this kind of money. you spend more money to think, so that eventually UST want to the building service this kind of thing to save the more energy efficient way. So they try to get rid of this kind of the unit for this kind of the humidity control to save money. So that then try to lower down the temperature. That's something is I tell you, still non-trivial. You need to find a balance. Why? So that that's why they try to lower down the temperature to lower, so that the temperature already is this is a typical temperature from recommended by Hong Kong government EMC. But in reality, if you don't want to think, then you have to control humidity, and then you, in this case, sometimes some this kind of business owner, they don't want to pay much more money. they try, I try to lower down temperature, and then so that in this case the humidity can be lower, but you be much super cold. That's something reality is somehow it's still non-trivial. I would say, and you say it's still non-trivial. It's non-trivial to have a very good this kind of human thermal comfort. And for building, HVAC is still non-trivial. But at the same time, you want to have the kind of energy saving and reduce the cost. It's still non-trivial. Okay, it's still non-trivial. Even I just tell you that our UST's case, right? So that this is non-trivial. Yeah. Anyway, so that we just tell you, gradually we, in the past 40 years, gradually we be responsive building. For example, we call that demand control ventilation. Is one of typical idea. Demand control ventilation, that this respond like ventilation is one of the idea. I happen to think, but that means one thing for air conditioning system in our commercial building, our USC building. So we have this kind of central, this kind of a cool air supply to every classroom offices, right? And then, but in case we have no people in office or no student in classroom, so what do we do? Can we add some sensor to see, okay, if no student in the classroom, we just automatically turn off, right? The air conditioning system. That's something is a demand, or we can sense according to number of students in the classroom, number of people in the office, and then that means we add additional this kind of a sensor. Most likely, I'll show you demand control. Most likely in old day is a CO2 sensor. So we can sense, usually using some kind of optical, NDIR, near infrared, this optical this kind of sensor. So that in this case, we try to monitor the number of people inside the building according to CO2 emission, right? Every of you have to breathe, right? Unless you die. so that everybody, if you are okay, and then no serious problem, and then you will regulate this kind of breathing, and then you will, everybody will have the CO2, right? So that the typical this thing, so that in this kind of demand control, that means we install this kind of CO2 sensor to send this kind of concentration CO2, and then we adjust this kind of ventilation system. Make sure we maintain the good this kind of CO2 concentration. So this, and then to save energy. Do you understand? So this is something is idea is having exist here. But what's the problem? In old day, this kind of optical this CO2 sensor is very expensive. So that not actually every building they want to install expensive this kind of CO2 sensor for this kind of responsive event, so that of course, as I mentioned, now everybody has smartphone doing that, so that every smartphone, new smartphone, iPhone 10, iPhone 12, gradually all smart have a lot more sensor, 10 or 20 sensor. So from my point of view, so in the near future, if we can leverage this kind of low cost, this kind of semiconductor or MEMS micro sensor, so that to make sure that we enable every building have local sensor for this kind of responsive smart building with this kind of AI or this thing, then I will see this is the way now we should think about in the near future, right? Smart building, and then with additional this IoT technology, right? IoT, Internet of Things, right? And then with AI, right? So that in this case, I can see that all this kind of ICT and advanced MEMS sensor AI will be gradually used in more and more building. So that is something quite important, right? So that I just tell you that in the, of course, I will mention some of these things, right? In gradually in following chapter, yeah. And of course, again, so typically, again, similar to what we mentioned in previous chapter, the building engineering is a system engineering thing. We do require engineering work on different part of subsystem. Do you understand? Subsystem means we have looked at of course, mechanical this kind of engineering design, mechanical design, and then fire safety, right? Security, water system, energy system, and communication system, right? And then also this kind of HVAC, right? In Hong Kong, most likely only AC only, air conditioning system, right? So that in this case, you can imagine for all this kind of subsystem, we are able to, for smart building, we are going to make more sensor, or maybe controller, or sensor with AI or some things, so, and all this kind of communication to the internet, right? IoT is saying IoT sensor with a smart control, so that we are able to do this kind of way to do this kind of control, right? And to save energy and maintain the good this kind of energy efficiency and thermal comfort. So all these things, I think, is clear. We will greatly have make much better this kind of intelligent and smart building. Of course, typically, so that for the whole building, we have a the BMS system, building management system. So that so this is a building management, actually typically BMS, building management, right? The building management system. So that actually many of this commercial building, most likely they have this BMS system. For example, from those big company like Honeywell, you know that USC we use Honeywell, the building management system for this control about the system. So this is something I just tell you that we do have a serious technology, and then some technology is mature, but some technology is still ongoing to be more intelligent and smarter. Okay, so that is something, as I tell you, this is something quite important for all of you to understand this kind of thing. Let me just to show you, like if I just show this kind of very simple way, maybe it's not good. So that I just show you some good example. UST, this kind of BMS, UST actually use Honeywell BMS system. Okay, so that then there's one control panel, right? In our building service and team, right? We're building this kind of service engineering team in UST, right? So that they use this kind of Honeywell system to do the control about the ventilation, HVAC, and electricity, and more. So this is very thing, right? So that this BMS system is what? Basically is somehow like I would say buildings operation system. probably this is easy for all of you to understand. Huh? BMS actually, I would say, is somehow the building's operation system. Right? In every computer, you have a Microsoft, Linux, right? Or Mac system. So that I would say building actually has their own building operating system, BMS system. So that actually it's also quite very complicated. Now, if you look at, I just show you like for example, like UST, the case, so that they actually it's quite sophisticated. This kind of building management system is not the simple. That require have some full-time engineer to operate this kind of BMS system. Full-time is not something like no plug and play. So that we do have full-time this kind of technician to take care about our UST. This kind of building MS is something. Of course, the question is how can we use this kind of more intelligent way for building many systems? Intelligent is not something we have this kind of engineer for long time to tune this kind of system. So this is something we are going to have. I would say smart BMS system, and then also additional space management, business management system. So that sometimes commercial building, we have many this office wide company and many kind of people here. So that they also need to look at this kind of build business management, right? Yeah. So that anyway, so that in general, so that all this smart building, again, the bottom line is very clear. We want to have much better efficiency, right? Energy efficiency and maximum efficiency of this kind of occupant, the user, right, in the building. Of course, you see, if we have some big problem and many companies shut down, like now COVID-19, so that I can see we have many restaurants shut down, right, in this COVID-19, this fifth wave. So that because so that you can see that that there's a lot more restriction, right? So it means you cannot have a dinner, right, in this restaurant now. So that many this kind of owner, right, will suffer a lot. That's something. Unfortunately, this is something quite important. And again, so that in general, so that again, similar to what we mentioned in previous slide, in previous chapter, every building we need to care about all the subsystem, right? And as each subsystem will actually have some, I would say, full-time engineer to take care about this kind of maintenance and operation. Okay, so this is something quite important, right? Of course, again, so gradually I will show you why, so that some of this one will be more and more intelligent. See, in general, I would say this part, security system, I would say this is the first thing. Gradually people will use AI, CCTV, this camera, so that nowadays a lot more this kind of camera will have integrate with this kind of simple image sensor, integrate with this AI, so that how we can create some more intelligent this kind of camera, right? Our smart TVs, smart camera, CMOS image sensor, image sensor. That means this means we use CMOS image sensor, right? Because sometimes like short name CIS integrate with AI, so that in this case we are able to more intelligent to use it for this kind of security monitoring about this thing. Do you say? So I can see this is one of quite, of course, all this CMOS image sensor of the camera will what have some kind of wider communication. That become very common. So that's why I told you we have a connected. In this case, we connect. This means that we can call this connected this kind of AIoT sensor, connected sensor, right? Sensor, right? This is the thing. Well, connect to the internet, and then so that in this case we are able to do a lot more, enhance this kind of function, right? So that this is something I can see that you will see a lot more. This kind of smart camera would be useful. So I don't know if can you try to make this kind of smart sensor, smart camera? I want to ask you, are you able to think about this kind of smart, this kind of camera now at home? Hey, I want to ask you, can you, do you have idea? Do you have some idea about this kind of AI, smart, this kind of camera, application at home or in your student home? Can you? I want to ask all of you, is that easy or not difficult? I want to ask all of you, do you think it's possible? Why? Why is it difficult? Why is it difficult? Because you don't know some new technology. I just tell you that there's an MIT Media Lab come with a very interesting this kind of AI this kind of thing. Try to change your webcam with AI, integrate your computer, your laptop computer. So you even at home you can make this kind of interesting this kind of using webcam with AI, do this kind of thing. You see, we do still say it's difficult, but I tell you, it really if you have new tools for do that, and then so that you can even the student in the primary school or student can play with this kind of AI with webcam. Do you believe? Do you believe that? Do you believe that you can the primary school student can do who can do this kind of AI with this webcam? No? What do you think? Primary school. You can do now. I just show you. For example, this is open source. That's why I have it. Open source platform. Not only good for building, engineering, design, but open source platform enable even you can think about this kind of AI with this kind of low cost webcam for this kind of thing, right? For AI, so that this is something is a new type of engineering. So that I will show you this kind of interesting Scratch MIT that they with webcam, and then so that with AI, so that actually you can really try to think about this kind of interesting project now with Scratch, open source. And I told you, open source platform, it becomes so important now. So that one thing you can use for this kind of like a video, you can make a video game or something, maybe use webcam for maybe object detection, detect human, detect using AI. So that I just quickly show you about this kind of amazing thing, why? So that this Scratch actually is very interesting new kind of online cloud computing platform, and enable you to use webcam for a lot webcam with this kind of open source programming platform with AI with things, so that you cannot imagine this is something now all of you can easily accept this AI with this kind of webcam with a lot more sensor. So that I just show you about this thing. If you have a chance, do recommend you can try to register account now from this kind of MIT Scratch, so that there's a lot more this kind of thing. Now AI with webcam with similar sensor can be used for a lot more this thing. So that do you say so? This is something before it seems it looks like play some game, but actually this is something quite amazing. Video sensing. In old day, video sensing is difficult, but this MIT Media Lab create this kind of open source. So even the this for K-12, the student, they can easily make using webcam, and then they can easily play with webcam with AI. You cannot, if you try to look at the Scratch, this kind of a website, and look at YouTube, you find many example how we can use webcam to do this kind of AI, to do many interesting project. So that this, I believe this kind of thing can easily use for potentially use for this kind of camera for building application, because it's low cost. And I told you this that kind of Scratch have been widely used by, I think, more than 10 million students. Okay, I mean in primary school. I mean like a 5 year to 12 years student in United States. How old are you? Huh? You can find this Scratch is something amazing, so that those students 5 year to 12 years old students can easily make a program. Think about using webcam with AI, machine learning, so that it's not difficult. They really MIT Media Lab really make this interesting platform. So I do recommend you try to register account, and then to think about if this kind of Scratch can be useful for building engineering, right? To think this is something I would say quite amazing. Scratch has enabled a lot more this kind of application in the building. So yeah, I recommend over you. Oh, one student, Kingnan Ku, also make OpenCV. Yeah, OpenCV is another platform, but my point is you need to buy additional camera, semi sensor, but this kind of Scratch, it means use, now everybody you have webcam for online teaching, right? So that I believe all of you have webcam now, but so that if you use Scratch, then actually you can really understand how we can use AI, machine learning with camera, and for a lot more this kind of application. But at this moment, because this many students is about, I would say 10 million to 20 million students, most likely is like in like age maybe 5 to 12, so that they try to look at it for 12, so that they make for fun. But from my point of view, this can be useful for our building engineering to come with how to leverage kind of very webcam is like ubiquitous, right? Yeah. Camera, similar sensor, like your smartphone have at least 2 camera, right? Your laptop computer, even desktop computer have this kind of camera, so that this thing, so that I can see that this kind of open source, this kind of open source, this kind of platform, right? This online, this kind of cloud computing, this kind of non-cloud, this kind of platform, right? Coding platform. I think it have created some big revolution. I cannot believe like that. No, like AI, original AI is so looks like okay, only computer science, but now it's not. I can see even now 5 to 12 years old student can play with AI with webcam. So many is interesting application. Doing that, I welcome you to now register account on Scratch. Now seeing so that this is something is interesting. Now a thing, right? I told you this IoT technology is not for fun, and then of course it can be, it's fun, right? So many students 5 to 12 years student, they try to make some very interesting video game, and maybe play some music or some do exercise. So that actually I do find there's one student try to make an interesting this kind of game for you to at home try to do exercise, doing that using webcam with this kind of Scratch, so that there's something, especially COVID-19. I recommend maybe you can play some game. Scratch. Now, this cloud computing will have 10 million people in the world. 10 try to at least 10 million people, student, most likely that they try to make an interesting this kind of program. Why? Scratch program with webcam, so many different applications. You can also enhance your health. Okay, anyway, I will share you about some interesting project I discovered about 1 week ago, so that it's fun for you. If you continue to online teaching, then maybe you can play some game with webcam and do exercise with this kind of online coding. Online people have done many interesting project on these things. So that again, so this is I do think it's fun for you to think about how to leverage this kind of advanced semiconductor IoT online this kind of cloud computing and integrate with this kind of sensor, right? The webcam or similar sensor, right? And this is something becomes so common. Yeah. And of course, another important thing is we for us, right? For our building wise, of course, our key thing is what? We want to try to make sure that engineer, what's the goal of engineer? Make a low cost, high performance product, machine or building, low cost, right? So that there's of course, there will maybe see it as we have this simple way, 4E, right? Low cost, economic, right? Low cost, efficiency, energy efficiency, effectiveness, and then outcome, and then so efficacy, so that effectiveness, how degree achievement of outcome for engineer, for company or something, or even for student, how you can maximize the efficiency for you to learn, right? This is a very important thing. So that in terms of building, right? Building, if our classroom or our school's building is clear, we want to have much better achievement of outcome for our school. How can you think about this kind of smart building, smart classroom, so it can be more efficient for learning? This is something is quite important. And so that anyway, so that one student asked the question about will we have a midterm be open book or closed book. From my point of view, it would be much easier to have a closed book, this kind of midterm online midterm exam, to avoid some cheating, because I do think the some students complain this kind of online exam has many possible have this kind of cheating, so that I will let this kind of midterm will be closed to and very fast close the book, to avoid cheating. And plus using Canvas technology. Canvas have web has this kind of technology to prevent cheating. Or Canvas, as I told you, we do have experience like in 1 to 2 years ago. Canvas have the technology to prevent this kind of cheating for online, this kind of thing. So that of course we also use this kind of webcam. Maybe what I should think about how to use this kind of Scratch now to capture this kind of video for using AI detect any student have a cheating or not. That's another thing, right? This kind of webcam, if there's some way we can have maybe using a Scratch, this thing like MIT Scratch, then plus webcam, and then plus AI webcam, and plus AI to see to prevent this kind of for online exam monitoring. Maybe it's something new kind of idea, new technology, and new business. You should think about have some new tech form a group of students to come with new idea. How you Scratch open source with webcam AI for this online exam monitoring, because in the world I will still have many students have to online teaching, online exam. So how can come with this new way, open source way to prevent cheating? I can see this is a maybe potential like a business thing. You may want to come with some new idea to solve the problem. So that sometimes the problem may be an opportunity for engineer, right? Our smart building is in general, right? We have a smart classroom, right? Or online. Online, this kind of teaching is virtual. This kind of classroom, right? Now we are online teaching, so that how we can use new technology, with webcam, with the AI, to enhance this kind of online, this kind of teaching, learning, and online exam. I can see this is something quite important. Anyway, so that again, so that the goal, I think we this part we already mentioned. I don't think we should spend too much, but in general, there's a lot more this kind of thing, right? For that, in general, I thought this is kind of building, engineering expert, so that we need to think about this kind of building is system engineering to deal with all things. And of course, typically, right, if you look at building, so actually the building most likely is not owned by one guy, so that it's owned by many people, stakeholder in more general sense. Right? That means the building probably owned by a company, or if you are a big company, you own like Li Ka-shing, have many building owner, right? And then some consulting, engineering, IT, energy, and site maintenance. There's a series of this kind of we can stakeholder for the building engineering, right? Each this kind of stakeholder will take care about specific this kind of building engineering thing, right? For the whole this kind of operation of the building, right? So that's something as I show you this in general. I was building it's a system engineering, right? Require many different kind of engineer to work together, and so okay. Anyway, so that I think this is not too challenging for all of you to understand. So of course, as I mentioned, I do hope that maybe you should try to understand more on this thing. Of course, and then gradually, if you look at more example, right? So that if we look at this kind of typical smart building, so that we are only see about this kind of light control, environmental monitoring, window control, motion detector, and thing. And all this one now, I can see we do have way to do this kind of IoT. What do you think? I do think now we have a lot more this kind of way to do this kind of IoT now, right? Especially with this kind of low cost semiconductor technology, wireless communication technology, like a Wi-Fi and internet. So that, for example, now I can see this kind of Alexa. I don't know if you have ever use Alexa smart loudspeaker. Anyone? Do you? Alexa is Amazon Alexa, but also in mainland China we have different Xiaomi音箱and other things. So that we do. I do have this kind of Alexa. So this is something it can be useful for this kind of smart building, smart home application. Do you understand? I just say this kind of IoT now is become much more mature, so that we can easily use this kind of Alexa for smart home, smart building. So that I don't know. Maybe I can easily you can look at this kind of example about Alexa. Amazon Alexa S is it's a quite interesting example how you can use this kind of IoT sensor for this kind of a new way for smart home, smart building. Okay, let me share you about this example, so that then you probably has a much more idea about this kind of smart home, smart building. It's something especially with low cost, this kind of a Wi-Fi or low cost sensor, right? So that this become very mature. I say mature. That means a lot of this kind of this kind of home appliance can be use this kind of AI with Alexa, smart loudspeaker connect to the internet.
Just arrived from Amazon. I didn't know what it was. What is it?
You'll see.
Is it for me?
It's for everyone. It's called Amazon Echo.
How's it going?
I'm just finishing up right now.
Is it on?
Oh, it's always on.
Can it hear me right now?
Nope. It only hears you when you use the wake word we chose. Alexa.
Well, what does it do?
Alexa, what do you do?
I can play music, answer questions, get the news and weather, create to-do lists, and much more.
Awesome. Alexa, play rock music.
Rock music.
Alexa, stop.
Wait, I want to try. Alexa, what time is it?
The time is 3:27.
You actually don't have to yell at it, okay? It uses far-field technology so it can hear you from anywhere in the room.
So it can just hear you anywhere?
Yes.
The far field technology means what? Actually, it's array of man's microphone, low-cost man micro sensor, about I was 6 to 7 of low-cost man's microphone, so that the array of sensor with this kind of smart sensors technology, they can easily adjust this kind of direction and sensitivity of microphone, so that far field they can really easily understand if one building, one room have some people try to talking, and then they easily try to do adjustment of this kind of microphone array to be sensitive to one person they are talking. So this is something advanced of this kind of micro sensor, low cost man's microphone. And several years ago, I do have project about this man's microphone. Okay, but this has become quite common now.
Well, everyone can hear you anyway.
Oh, is that where we're going to put it?
I was thinking of putting it there, but it works anywhere.
Echo is pretty neat because it knows all sorts of things.
It's on
All you have to
Tuesday.
do is ask.
Alexa, how tall is Mount Everest?
Mount Everest's height is 29,029 feet, 8,848 meters.
How can it know so much? It's so small.
It updates using the cloud. That's also how it gets its answers.
Just read that off the box, huh?
Dad really likes that Echo just plugs in, so we never have to charge it. Plus, Echo's really good at keeping track of things like shopping and to-do lists.
Paper. Alexa, add wrapping paper to the shopping list.
I've put wrapping paper on your shopping list.
Alexa, how many teaspoons are in a tablespoon?
1 tablespoon equals 3 teaspoons.
Okay. Alexa, set a timer for 8 minutes.
8 minutes starting now.
Dad's not a morning person, but Echo definitely helps him wake up.
Alexa, alarm off.
You gotta get up.
Oh, it's Saturday.
Alexa, what day is it?
Today is Thursday, November 13th.
I'm up. Alexa, give me my flash news briefing.
Here's your flash briefing.
From NPR News in Washington, I'm Lakshmi Singh.
Mom, what did the dog say after a long day of work?
What?
Today was rough. Get it? Get it?
Yeah, I get
it. Another one.
Alexa, tell me another joke.
I wondered why the baseball was getting bigger, and then it hit me.
Sometimes Echo helps out when you least expect it.
Hey, Dad, how do you spell cantaloupe?
Cantaloupe. C-A-N-T... Alexa, how do you spell cantaloupe?
Cantaloupe is spelled C-A-N-T-A-L-O-U-P-E.
Good job.
Echo loves to play music and knows a lot of songs, and they always sound great.
Alexa, play my dance mix.
The playlist dance.
Alexa, stop. Alexa, define annoying.
The term annoying means 1, causing irritation or annoyance.
Example, my brother.
And with the companion app, you can access Echo from anywhere. With everything Echo can do, it's really become part of the family.
To experience Echo, go to amazon.com/echo.
Hello, here let's give you some examples so that this Amazon Alexa can be used for a lot more application, as mentioned in our slide, so that for lighting, for air conditioning system, they really can control many many this kind thing in smart home or smart building. So that it's not something difficult now. Why doing that? So that if you maybe I just show you one simple example about the lighting. Right, the lighting is something. No, you just use voice and ask this kind of Alexa, it can really control.
What's going on, guys? Welcome to my house, and today I just want to show you guys a quick demo of Amazon Echo controlling all the lights in my home. And this is something I've wanted to do for a long time, and I wanted to get all of them linked. I finally got every single light in here working now and connected to the Amazon Echo, and I just want to show you guys how it all operates. I've got it set up on groups as well, so that way if we have multiple lights in the living room, it will turn off all the lights in the living room just by saying living room, instead of having to turn off each one individually. So let's show you that real quickly. You'll see there are two lights on the opposite ends of the large balcony door. And if we say, Alexa, turn off the living room lights, it turns off the ceiling lights as well as the two up lights on either side. Alexa, turn on the up lights.
Okay.
Alexa, turn on the living room lights.
Okay.
Alexa, turn off all the lights.
Okay.
So it can also control all the lights. That is one of the groups I have set up. As you can see here is the kitchen. Alexa, turn on the kitchen lights.
Okay.
Alexa, turn on the entry lights.
Okay.
In my bedroom, I have a couple lamps here as well as that pendant light up there. So Alexa, turn on the bedroom lights. Alexa, turn on the bedroom lights.
Okay.
So you can see we've got this bedroom lamp connected as well as this light right here and as well as.
Okay, so here I just tell you that what we mentioned in here, we do have this kind of smart home control lighting, and of course you can also control TV, control this air conditioning system, and this has become much more mature. I see, like 20 or 30 years ago, I can see it's still very difficult, but with this kind of advanced semiconductor, local sensor, micro sensor, and wireless communication, so that all this become much more become visible to everybody, every home, right, and every building. I can see this has become, of course, this also this kind of Alexa is basically you have additional this AI on the cloud, right? Doing that, so that this Alexa, they try to collect those sound and then use AI. They can really try to understand about the voice, and then using your voice to control so many different kind of smart home applications. So this is just something I can see is a lot more mature, and then so that open up a lot of these new technology, new business, and why, and some of you, if you leverage this kind of new technology, you will be super rich. What do you think? If you try to think about this kind of a new technology for building engineering, so that you can become you can make big money. What do you think? Do you think it's possible? Any idea? If you come with some new, this kind of smart, right? Smart building, some components, smart lighting, smart air conditioning system, can you become the billionaire? What do you think? What do you think? If you have a good idea about this kind of smart, this kind of building smart home, and you can get rich. You can get rich. That's something is possible. Okay, with this kind of IoT technology. What do you think? One example I show you is, for example, the Google acquired one small company, start company in Silicon Valley to what? Smart air conditioning system. And then this is one very simple example, Nest Lab. So that Nest Lab is one example about this kind of some smart thermostat. So that Nest Lab actually was acquired as a small company, acquired by Google for about $2 to $3 billion US. Can you believe? Huh? I just show you. It's not just talking. I just show you one example. Nest Lab. This is a thing, and then so that this is company. They have idea about self-learning thermostat for air conditioning system, and then suddenly they self-learning. Then suddenly they not suddenly. I mean, do the good business and acquired by Google for I think $2 to $3 billion US. Okay, you see. So this is something 2 to 3 billion. That means it's not small money. So what do you think? So that with this kind of new kind of idea about smart, this was Nest Lab actually this is about 2 to 3 I think billion US dollar. From acquire Google acquired this kind of Nest Lab with 3 billion. Okay, can you come with a new idea? Can you come with a new idea for this kind of smart home, smart building? Then get rich. This is something is quite important, right? So that here we just tell you some very simple this kind of introduction, but I can see that with this understanding about this kind of new idea, right, in this area, so that it's possible you really some of you can have an opportunity, right, to come with something interesting idea. Okay, and of course there's another company, smart I think door lock, smart door lock, right, acquired by Amazon. Also by I think the money is also not that $1 million is a big money. So it's all this kind of smart home application has opportunity for you to get rich. Okay, so that's how you see. And anyway, so that I just tell you that in general, for us to look at smart building, so that we are in a way to look at much more this kind of how we can have more environmental friendly, smart, like a human thermal comfort, energy saving, and the other thing, human thermal comfort or efficiency, and other thing. So that these are something quite important, but require construction. So that of course, as I mentioned, construction is something a big problem in Hong Kong or in mainland China. So that at this moment, all the building construction is like industrial 1.0, 2.0. So that how can we make smart construction, right? So that's why so that smart construction or AI for construction, so that enable me and my colleague, Professor Zhe Xiangli, we got 300 million Hong Kong dollar project. So that so that even not a company, if us we come a new idea, smart construction, we receive 300 million Hong Kong dollar funding from Hong Kong government. And then so that I welcome you to, of course, I will try to invite some of this kind of manager of Hong Kong CRC to see if you are interested about this smart construction, building construction thing, right? So that we have about 50 people, and in this kind of 300 million dollar, this kind of research center, right? So that how you come with some smart construction, building construction. So you are working if you're interested to work some intern or work on some project, and with this kind of full-time, this kind of RA, and then so also postdoctor here. So of course we are welcome to do something, right? To learn about this kind of smart construction with AI, with also automation, because locally in Hong Kong, we do have problem. Do you know what's the problem of construction industry in Hong Kong? Any idea? What's the problem? What's the problem of construction industry in Hong Kong? What is the big problem now of construction in Hong Kong? One student say too many projects. Well, too much can make big money. One was not a problem. Safety issue. Okay, Why Ching also safety. Of course, efficiency. Kingdom also mentioned efficiency. This is, I think, in general, it's true. Why all the building construction, we need a group of construction workers work very hard. See, can we have more this kind of automation to do the building construction? Not only the human. Well, why using robot or automated machine to do this kind of construction, or with even AI for smart building construction. And of course, that's something. Of course, another big problem is all of you don't want to work as construction worker. So that average kind of age of a construction worker in Hong Kong is very high, about 50 years old. All of you, do you want to become construction worker? Anyone? I think the salary is high. Do you want to become a construction worker? Do you? I think now they really, one of the big problem is average this kind of construction. The average age of our construction worker in Hong Kong is about 50 years old. Many of you don't want to become worker. No. So that this is a big problem. That's why we got 300 million Hong Kong dollar project to help the local industry, even in mainland China. We lack of, especially in this big Bay Area, we lack of this kind of workers for building industry. So that this is a big issue. So that's why construction, we need more and more automation, more and more this kind of using robot or some automation to do this kind of building constructions. This is something very important. Right? That's why we have at least we have about 4 to 5 team work on different aspects of smart building construction. Again, if you are interested, so about things do some co-op or some interns, so feel free to contact me, and I can ask our manager to see if you can have some idea about the, at least have some understand more what as a UG of this kind of intern or something. Yeah, that's it, or some project. Okay, and of course health sanitation, that's another so serious issue now. So that especially in COVID-19, so that can we really have this kind of way to make sure that again kill those COVID-19 virus and make sure everyone healthy, right? This kind of virus is so small, it's suspended in the air. The aerosol, bioaerosol is very suspended, so that and unfortunately, if one building will have several confirmed cases of this virus, COVID-19 virus will continue to spread, right? Inside the building. So that is one of the big problem now, I would say, And anyway, so that here I just tell you, in general, we have a lot more of this kind of thing. Why? So that the lighting, we have smart lighting, and then again, as I show you, Amazon Alexa is one example. We can really use this kind of IoT, AIoT, wow, artificial intelligence, who can really understand about your voice, right, to control lighting with this kind of Wi-Fi, and then of course we have a lot more. Can we come with additional smart air conditioning system? This also something I show you. Google Nest Lab is a way, why, so that the Google Nest Lab is kind of this kind of smart thermostat is example about this kind of smart air conditioning system. So we do have a series of this thing, and then of course in the future, how can we have this kind of smart indoor air quality monitoring. Monitoring not only maybe CO2 or some bad this kind of pollution, and then monitoring this kind of COVID-19 virus in the building or contaminant is become quite important and thing. Yeah. At the moment, I can see still we have no kind of product for this kind of low cost biosensor detect COVID-19 in the building, so that this is another opportunity for you. Why for some of the young students, they want to get rich. Why you have invent some new smart biosensor for smart building to detect this kind of bacteria or viruses, and then there's another. That means every of this one can come with good technology and good company and get rich. This one still difficult, but I'm pretty sure this is something important to think about how we can do monitoring about this kind of indoor air quality, right? And monitoring and control, right? Make sure that become more healthy building. Yeah. And anyway, so that here I just show you like we are mentioning some a series example now, so that this is something not the maybe I should try to show you about that $2 or $3 billion dollar this kind of smart thermostat, and then at least this is a product. Why our presentation slide is only gave us rough idea, so that this is something. Let me show you about this kind of smart thermostat, so that actually I think there's a lot more this kind of company try to make similar this kind of product, not only Google, right? But at least I just show you, right? This is this kind of idea and product was $2 to $3 billion US dollar. So that why now you try to understand the basic. Fair learning kind of technology. If they can understand about you have control about this thermostat and maximize comfort, thermal comfort, and energy efficiency. Learning. Yeah. Again, so this idea and this product costs $2 to $3 billion US dollar. Can you believe? Can you make better? That's another thing. One thing. So that this is important for you, right? So that all the smart building, this component is has some new opportunity for all of you to think about, right? This kind of thing. And of course, when we look at this kind of building, and then so that it's really important for you to think about a little more detail about issue, right? So based on real limitation of ordinary or conventional building, can you really try to make some good the kind of smart building this component, why or module? Why this is thing Alexa? I just show you Alexa. Actually, I have to show. I bought this one as to use. Why even in my office, I also have this Nest Lab, so that for at least it's something I can see this is a useful information for all of you to think about. Yeah, and of course, communication is another quite important for the building. Why? So that intelligent building definitely need a lot more of this kind. Not only the typical old communication, telephone, we have a wired internet, Ethernet, Wi-Fi, LoRa, 5G for Industry 4.0, And then for one of the 5G, and people also think about we have smart grid, smart HMAC, and VR, AR, MR, right, for building BMS and a lot more AI-based communication system. So all this will become quite important. So what do you think about VR, AR, MR? Can really make some better this kind of VR, AR for building or building construction or some smart this kind of a building smart construction. It's clear VR, AR, MR will be very important in the coming several years, especially if you look at like Facebook founder Mark. He also changed the company name to Meta, so that the metaverse is, from my point of view, is continuing extension about this kind of thing, VR, AR, MR, and metaverse. So what do you think? Can you think about this thing? So basically, this is a combination of physical world, physical building with virtual world, virtual building. So that metaverse is something many big company, right? Not only Facebook, Google, Microsoft, they are really think this is a big opportunity, right? So that what do you think? Can you come with some new idea in this area, right, and get rich, especially so that when not only virtual, we have the real building engineering. You may also think about how can we come with a virtual building, virtual land, right? I mentioned to you, right? So that sandbox is virtual like a world, right? One of the metaverse, so that they really sell land and sell this kind of a virtual building and many things, virtual this object for in the virtual building, and then make money. So that what do you think? Can you also try to create some virtual building, not on the physical building, right, in this metaverse? So this is something I think is quite interesting for you to think about this thing, right? So that if you are going to there's all the new technology, so definitely this kind of virtual building is somehow, I would say, useful for you to think about. Why, if you cannot afford real building or buy this kind of apartments in Hong Kong, then can you think about the virtual building, virtual apartment? So that this is something I just show you about this thing. So that this is that means in this kind of virtual world, you can really build some video game or build this kind of virtual like object, so this is quite amazing. So that you see and can make money. You cannot I cannot believe that that's really have so many these things. Of course, as I mentioned in the first lecture, so this kind of virtual world, people also buy. One of the most expensive land in this sandbox is more than $4 million US dollar, right? Do you understand? So this is something, it's quite interesting. So that can you make some interesting virtual like a building, virtual this kind of home, virtual this kind of object to sell. Chinese, you see, Chinese architecture sell for more than 300 US dollar. What do you think? I guess probably you can build this kind of thing, and try to sell on the virtual land sandbox. What do you think? Can you make this kind of thing and then sell? That's quite interesting. So that this kind of new kind of metaverse creates some new opportunity for all of you. Not only the building engineering, but in the virtual world, there's another new branch of virtual land, virtual building, virtual this kind of a design of this kind of object to sold on this kind of market. So this is something personally I was surprised, but it seems this become very hard. Of course, they also need the virtual money, cryptocurrency to buy this kind of virtual land. So this is something I think it's interesting for all of you to understand the new technology. Either do you have any question about today's lecture? Again, today we just quickly mention about smart building and a series of example, right? Not only on lecture note, but show you the real this kind of smart building, smart home application. Definitely this kind of local sensor, wireless communication, and with AI become more and more real now with smart home, smart building. Okay, and do you have any question for today's lecture? Of course, I do recommend you try to play with this kind of Scratch to see can you come with some new kind of webcam with online open source Scratch, and then so that for some building application. So doing that, so that's something even now for 5 to 12 years old student can make this kind of thing. You may also try to look at some typical example. I also try to make one example on our Canvas website, so that for you to, again, I do encourage you to look at some additional supporting this kind of reference. Definitely, I will show you some of this kind of webcam. People use AI and then make a series of into program now with open source Scratch made by MIT Media Lab, so that I can see it should be able to use for the building application, not only for video game. Okay.